Good morning, good evening, welcome back to the show. We're here again today with the FE290D engine off of the 1993 Kawasaki Mule FE290D. And today I'm going to kind of get you caught up on where we are on this. I've got some exciting stuff to share later on. I've already taken this apart, but I'm going to kind of go through it just to show you what steps we took. So let's get going. Since we've already identified in a previous video that the starter here has some issues and we need to fix it, let's go ahead and get it out of the way. You've got two 13mm bolts right there. And you can gently remove your dipstick tube and pull the starter right out. With the starter removed, it actually gives us a nice little grab handle that we can maneuver the engine with. Next thing we're going to move on to is the rocker case lid or valve cover. So right here we just have two 10mm bolts. With those removed, we can remove the rocker cover or the valve cover to expose the rockers below. And here you see the rockers and the valve springs. The side closest to us is the intake side. That's where the carburetor was mounted. What the factory service manual recommends next is that we get the engine to top dead center. It's already there, but let's go ahead and just get back to, I'll just show you how to do that. And if you're ever in doubt as to which way an engine turns, you can use the fins on the flywheel to give you an idea. It's going to be a cup, and it uses those fins to cup air and push air around. So the engine moves this way, and you can see I've already got this off here. But what we're looking for is a place where the magneto just passes. We're trying to get to top dead center, and you want the rockers totally free, which is going to be immediately. It's right after the compression stroke and right before the power stroke. So right here, right after that, and then we can feel our rockers up here, and well, this thing's not tight, but we're at top dead center. We'll just verify that again whenever we get in there. Okay, and that's the kind of play that you're looking for on both of those rocker arms. So the next thing that we need to do here is there's 6 12mm bolts that were in these holes right here, here, and behind here. We'll remove those, and then we're ready to take off the cylinder head. And I believe the purpose in getting you to top dead center on this was to take off any of the pressure on these rocker arm push rods. These rods go all the way through down into the crankcase, where they're actually making contact with the camshaft, I believe. So let's go ahead and pull this off, and we'll just lay this here. There are those rocker arm push rods I was talking about, and I don't know if you can see this yet, but take a look at this head. That right there is a very burned exhaust valve, which is good news for us, because the reason that I think we're looking at the reason for the bad compression. And you can even see, if I push that valve, I'm going to push the other side of this with my finger, but if you push that right there, that thing, there's no way that it's making a good seal there and would be able to hold compression. So let's take a look at the piston here, and this is also good news. If you do this back and forth, of course I've already put a little bit of Marvel Mystery Oil in there, but I can't feel any lateral movement back and forth on that piston. And if we spin this around here, let me get you in here, I don't see any kind of scoring on those walls there. That piston moves freely, and I feel like the rings inside are doing their job and keeping a tight seal there. So that's good news, because we may not have to get into the guts of this thing, and can just focus on the head itself. So with that, let's take a look. I'm going to need to order some parts. I'll put the list of parts up on the screen. I've done a little work in trying to find someone to clean this up for me. essentially what I want done is, you want to take all this apart. You'll replace the springs there, these valves that run all the way through here. I think maybe you can clean those up. I would just as soon as, for the cost, I'd like to just go ahead and replace them with new valves. And so it looks like, usually it starts with your exhaust valve where, if it's not sealing properly during the combustion stage, there's combustion that actually, it leaks past the valve and causes additional charring and burning. Anyway, and then if it's bad enough, it actually leaks over, and the same thing happens to the intake valve. So we're gonna get a list of parts together and figure out the next plan of attack. But I think this is the point where we outsource some of that work, because I don't have a machine shop that's I wouldn't be able to do all the cleaning that needs to be done. And so anyway, let's move along to that list here. Highlighted is everything we're going to replace on the engine. We've got the gasket there. We've got these valve guides here, a couple of snap rings here. It's important to note that these valve guides, this 49002, is this piece has been discontinued, and from what I can tell on various forums, they have just gone to the intake valve guide only, and you just use it for both. So save yourself some time and just go ahead and get the two intakes, because this one right here no longer exists. In addition, we're going to want to pick up the valves, the spring seats, the oil seal, 2 new springs, the valve spring retainers, and 4 of these collets. I was able to source all of those parts from Babbitt's online. I think the total was around $115, including shipping. That brings our total cost for this project to about $315, because the original bike was $200 plus the $115 for the parts to this point. So I'll update that total as we continue to put more money into this money pit. Okay, so I have my bag of parts here now, $115 worth. And I've spoken to a gentleman locally who is willing to take a look at this and see if he could do something to, kind of machine down right underneath. I don't know if you can see that. Right underneath where these valves sit, there's going to be some seats in there, and the purpose, you want to get those seats to a certain. It's like a ring that you want the thickness of that ring. You want the valve to fit in there just right. And they do 2 things. They seal, and they also help to dissipate heat. So anyway, I've got a guy that I'm going to take this to look at and see if he can just kind of clean all that stuff up for us, and go from there. If you wanted to buy this entire assembly, I guess minus the springs and all that, I believe you could get the whole assembly for $180. I was quoted by the first shop. They quoted me $180 just to do the work that we're talking about down here, and I told that to the gentleman here locally, and he was appalled by that. So I'm excited at his anger of high prices, because I don't want to put too much money into this, but at this point, I would probably pay $100 or something just to get this work done, because I can't do it myself. So I will pick back up after I have this back and after that discussion has been had. So see you in just a second. So while we're waiting to get that cylinder head back, I decided to take another look at this starter. I rigged up a little setup here with a battery and a switch, and I'm just going to try and see if I can maybe take a look at the actuator inside there and see what that thing's doing when we put it in a kind of a simulation here. So the connections we've made here, we've got the neutral is connected to the frame of the starter there. I've got this orange wire connected to this top post here, and then this little hot wire is connected in line with a switch here that goes to this terminal right here. So I'm going to flip this thing over, and I'll show you what it does. And moving this gear around, I don't see any evidence of tooth damage there. Everything looks pretty normal. So let's just do a little a test. And that's exactly what that's supposed to do. So I'm not sure what my deal was earlier, but we're not going to, I don't want to touch this starter. We're just going to, whenever we get the cylinder head back, we'll attach it back to the engine and go from there. And here is the cleaned up cylinder head back from Chuck. Oh my gosh, this thing is beautiful. Just look at that. Look at that. That is so nice. So at this point, let's go ahead and get that thing back on there. We're still at top dead center right here, so should be just a matter of bolting it down. Alright, we got ourselves a new head gasket here. We just need to get the other one off. Kind of get a razor blade and just kind of try to sneak that thing in on the side somewhere. There we go. You don't want to mar that undersurface, but you can just kind of use that as a little bitty wedge. All right, here we go, and we'll clean that up a little bit with some brake cleaner. And this head gasket only goes on one way, so there's no way that you can really screw this up. Otherwise I would. Now we're going to take just a little bit of engine oil and rub it on our rocker arm push rods. And we'll put those right back in there. Alright, and now we can just take these holes and just try to ease it down in there where they catch right there on the rocker arms. And we're going to tighten these down to 18 foot-pounds, which is also 216 inch-pounds, so 18 times 12. Also, the order that we're going to go in is 1, 2, 3, 4, 5, 6. Okay, so we're at 216 foot-pounds, and don't give me any slack for using an extension here, because you know, some of these you just can't get to any other way. So we're gonna go 1. This is 2. And this is 3. This is 4. This is 5. And this is 6. And we'll just rinse and repeat until we get that torqued up. And that's 6. And the factory service manual calls for 0.12 millimeter, and you can see that I have a problem here because I don't have that size. The 0.005 inches is actually equivalent to 0.127 millimeters, so I think I'm just going to use the 0.13 millimeter. And if this thing, after being 30 years old and all the abuse it's taken, can't handle a 7/1000 of a difference on the valves, then I don't want it anyway. So anyway, we'll get that in there, and we'll also use a, what else do I have here? I've used these in a previous video. I kind of like these for the way that they can grab the end of that, and then we'll just use a 9mm wrench to get the the other side of that. All right, and this has a torque of 87 inch-pounds. All right. Okay, I like that better. So 87 inch-pounds. And one more test. That's good. That's good. Okay, valves are good. And I want to give a quick shout out to a viewer that commented about my previous valve adjustment video and cleverly pointed out that I was not using the correct, correctly pointed out that I was using inches instead of millimeters. So you want to make sure that whenever you're doing this, that don't be a goofball like me and use the correct standard. Okay, we've got a new gasket for the rocker cover, so we'll get that on there. Now that thing is just shining. I really can't believe how well it turned out. Okay, so I guess that's all there is to it. There's that, and I could not find a specification in the book for the torque on this, so I think we'll just just wing it, get it kind of tight, and go from there. Our old friend, 10mm. And that feels snug enough. So I kind of want to check compression and see what the improvement has been, but I don't feel comfortable in doing a whole lot of that without oil in it. So what I think I'm going to do is go ahead and just change the oil filter and put a new put some more oil, and then we can test new compression. And here's our old one. Let's see if our new one. Let's see if the here we go. 490652071. So there we go. We'll put this new one in there and go from there. All right. Some nice little packaging here. Get us a little 5W30 on there, and I assume it's like every other oil filter. You snug it up and go 3/4 of a turn, 2/3 of a turn, something like that. All right, there's my finger. Okay, looks good. Okay, and we can put 1.4 quarts in here, and the factory service manual calls for 10W40, 10W30, 10W50, 20W40, 20W50. Yeah, so we're just going to use 5W30 and it'll be just fine. Okay, the oil's in, and I think we're ready for our compression test. Just want to make sure you can see that. All right, look at that. All right, so that thing, what are we getting there? I'll blow up my drill. But that thing is getting up close to, what's that, 70 PSI, so that's way better than last time. Happy with that, and let's see what we want to do next. It's getting pretty exciting. I just keep dreaming that we're finally going to get it back in its rightful home. Before we lose daylight, I'd like to try to remount the starter here and see if we can make it using our kind of rig, see if we can make it turn over on its own power. Okay, so everything's connected to the battery. The negative is grounded to the frame, and the large 6-gauge wire is connected to the positive lead of the starter solenoid, and a small lead is connected through a switch to this terminal of the starter solenoid. So we're going to flip the switch and see if we can get it to turn over. Absolutely wonderful. That's exactly what we want to see. So I think that's a success. we're losing daylight, but I think we've done enough for today. On our next, I think the next episode, I think I'm going to clean the carburetor and install this, and maybe try to just shoot a little gas down in the hole there and put a spark plug in there and see if we can't get it to actually run on the bench before we put it back in the mule. So if you liked the video, please give it a thumbs up. Consider subscribing. We've got a lot of stuff on the channel related to budget projects. There's some ATV stuff, home auto repair, maintenance, that kind of thing. So until next time, thanks a lot, and hope you have a great day.